Okay, we're going to start chapter 3. 3.1 is called linear models. So actually 3.1 we're going to work with lines, but a lot of it is actually going to be word problems because I would like to think that you have lines pretty well mastered. You just really need to work on, can you interpret a linear word problem? Okay, so then real quick, things you need to know about lines. You need to know that this is the, slope-intercept form of a line because it has slope and y-intercept. You need to know how to graph a line. Okay, we reviewed that and maybe struggled through it a little bit while we were together earlier, but you've got to know how to graph a line. Domain and range of a line, all real numbers, both of them. However, the domain and range is going to change once you start looking at real word problems because they're only going to exist in quadrant 1. Okay, how to tell if a line is increasing or decreasing. You know that, reading it left to right. How to solve for the intercepts of a line. Same way you solve for any intercept. If you're solving for an x-intercept, that's when y is 0. If you're solving for a y-intercept, that's when x is 0. Okay, let's see, how to solve for intersection of two lines. That one I might actually write something down for. You set them equal to each other. That's what you do for any intersection, whether it's lines or quadratics or a line and a quadratic. Okay, and then this is going to be the big one. This is what we're going to spend a lot of time on, interpreting the slope and just doing word problems in general. Okay, so I have this first example here. Okay, a company just purchased a fleet of new cars for its sales force at a cost of $28,000 per car. Okay, so then the company chooses to depreciate each vehicle using the straight line method. Now, that straight line method it's talking about here, that's going to come up in your homework, okay? All that means is, it says it right here, this means that each car will depreciate by $28,000 divided by 7, okay, if they're going to depreciate it over 7 years, that means $4,000 per year. Okay, so then this is what you need to be able to do. You need to be able to do all these different parts for this one situation. Okay, part A, build a linear model that express the value v. Okay, so value is going to be our output, our y, of each car as a function of its age. So that's going to be x, its age is going to be the input. Okay, so I'm going to have you pause this video. I want you to try to write this. Go. Okay, so the value of the car, so since it says to use value function, it starts off at $28,000. And then from that, you subtract $4,000 for every year that has gone by. So 4,000 times x. Now, normally we put the x first, and then, so, this is our slope, a negative 4,000. It's losing value. And then this is the y-intercept, and usually those are the other way around. But you can write it like this too, because I think it makes more sense with the problem. It's starting off at $28,000, and then we're subtracting this amount. Okay, what is the implied domain of this function? Okay, well, the domain is its age. Okay, well, obviously the car can't be, it can't have negative years. So x is greater than or equal to 0. Okay, you can't have negative years. I'll write that down. So implied domain just means, okay, based on the word problem and based on what's reasonable with the situation, that means implied domain. Okay, because obviously the domain of this line, if you were to literally plug this into your calculator, it's going to show you the whole line, all real numbers. Okay, but implied domain is what works specifically to this situation. Okay, what is the value of each car after 3 years? That means evaluate V of 3. So you plug 3 in and you get, pause, plug that in, $16,000. Okay, now this is the big one, interpreting the slope. Okay, I want you to do this every single time you're asked to interpret slope. Slope is, you learned this way back when. It is a change in y over change in x. So I want you to always write this down. Okay, then what I want you to do next is I then want you to apply this idea to this specific problem. A change in y in this problem is a change in, right here, value. So change in, value over change in, what's the x in this case? So specific to this problem, x is age in years. Okay, so basically the slope is how much the value changes per year. Okay, well, the slope in this case is negative 4,000 over 1. So that means you're going to write a nice sentence for interpreting the slope. Value decreases by $4,000 each year. There you go. No, yikes. Each year. Okay. We're going to practice some more of that, but this whole idea of taking the time to write this out and figure out what each of your variables is super important if you're going to be able to interpret the slope correctly. Okay, when will the book value of each car be $8,000? Okay, when will the value, that's the output, equal $8,000? So we're going to set our line. Okay, sorry, I'm going to apologize for all the sound in the background. My 5-year-old is playing back there loudly. Okay, so that looks like 8,600. That's 8,000. Okay, so you're going to solve this equation. So pause. You should get x equals 5, and that's in years. So x equals, and you always have to have units with these word problems. X equals 5 years. Okay. Next, I have a bunch of vocab that I want to make sure you know, because we're going to talk about money and supply and demand and that kind of thing. That's often linear. So quantity supplied is the amount of a product that a company is willing to make available for sale at a given price versus the demand, the amount of product that consumers are willing to purchase at a given price. Okay, so supply and demand really has an impact on price. Okay, so, actually just today I noticed how low gas prices are. Why is that? It's probably because demand is so low. People aren't going very many places, so they're lowering the cost. I'm not saying that's the only reason, but that's probably one of the reasons. Okay, equilibrium price is when quantity supplied equals quantity demanded. Okay. And then equilibrium quantity is the amount demanded or supplied at the equilibrium price. And then last, revenue. You've maybe talked about this in other classes. Revenue is the amount made after costs are met. Okay. Alrighty, let's see. So example 2, which is actually the last example for the day. So suppose that quantity supplied, which is often called S, and the quantity demanded, D, of cell phones each month are given by the following functions. So we've got a supply function and we've got a demand function. If I ask for the equilibrium price and quantity, okay, so just from the last slide, equilibrium price means supply equals demand. Okay, so we're literally going to set 60p minus 900 equal to negative 15p plus 2,850. And I'm not going to show the work for solving this. This is solving a basic algebraic equation. You pause, get this solved for. You should get p equals 50. Okay, now this next part is really important because I always get a bunch of questions on this. That is the price, okay, where supply and demand are equal. Now, it also asks for the quantity. So this is the big question. People always ask, okay, which one do I plug it into? And I'm not going to lie, I'm not going to call it a stupid question, maybe a silly question. My 5-year-old freaks out when I say stupid. Okay, don't say that, Mom. Here's the thing. The reason it's silly is because you just solved for when these two expressions are equal. Guess what? It doesn't matter which one you plug it into, you're going to get the same answer because that's the price that you get the same answer from each of them for. So you get to pick. You're going to plug it into supply, you're going to plug it into demand. It doesn't matter, you'll get the same answer. I'm just going to do supply, S of 50. So if I plug that in, get 2,100. Okay, so then writing your answer nicely, the price is, the equilibrium price is $50. And the equilibrium quantity is 2,100 cell phones. Okay. Determine the prices for which supply is greater than demand. Well, okay, so that means supply is greater than demand. We literally just, that's basically what we just did up here, except instead of this equal sign, we'd have this, right? And I don't think we ended up dividing by any negatives up there as we were moving things around. So since we didn't have to divide by a negative, it would just be P when the price is greater than $50. Okay, now you'd have to be careful with that. You got to make sure you know that the sign is going in the right place, because if you did divide by a negative, you'd have to flip that around. Okay, so then it also says to graph these and label the equilibrium price. Well, the first one, okay, so I'm going to get used to just graphing in quadrant 1 because that's where these are going to exist. This is price. Input is the price, and then the output is the number of cell phones. Okay. Alrighty, well, the supply had like a negative y-intercept. Let's see. So then it's going to come up, I don't know, something like this. There's supply. And then demand has a y-intercept of like 2,850. So it's way up here. So there's demand. Okay, so then the equilibrium price is where they intersect, right? I wanted a different color. Right here at that price of $50. The quantity is 2,100 cell phones. Okay, so there's a picture with the equilibrium price labeled. Okay, so your homework on here. This is what you need to be working on today and emailing me if you have questions.